Will, Taylor, welcome to Crystal 1.0 conference. Very glad to have you here. I should mention the fact that you both are part of the Volk Cooperative, which is a fairly interesting concept, and I was really delighted to go through the website of the co-op and check out a bit of what you do, and it sounds very, very interesting. So excited to have you here. And today you're going to be talking about how you built a product around cloud native with Crystal. And so great to have you here. Please take it away.
Good day. So this is about our journey with creating a test suite in Crystal for the cloud native community. We're going to talk about all these things, introduction to it, and talk about why we chose Crystal for a test suite and some of our obstacles and wins along the way, how you can get involved, and then at the end, that Q&A. So as mentioned, we're part of Volt Co-op, worker-owned co-op, and we're a geographically distributed team providing consulting, development, and DevOps services. I'm Taylor Carpenter, co-founder of Volt Co-op. I'm also a co-chair in the Cloud Native Network Function Working Group. When you see network function, we're really saying like a network application. This within CNCF. I've been an open source advocate and Linux user since the mid-90s and doing software development and DevOps pretty much all that time. Co-speaker is Will Harris. Will?
Hi, everyone. I'm William Harris, co-lead maintainer of the CNF Test Suite. A little background about myself. Throughout my 10-plus year career, I built software for projects with tens of users to hundreds of millions of users for tech giants like LinkedIn, venture-backed startups, and open source projects. And most recently, I've been working on Will.vc, based in Miami, where I help various customers tackle full stack web, mobile, and site reliability engineering software challenges. I've been helping the CNCF with the Cloud Native Telecom initiative since 2019 and working with the Volk team off and on since 2014. So take it away, Taylor.
All right, thanks. Thanks, Will, both times. Within the Cloud Native Computing Foundation, we built this open source test suite, and it's focused on helping networking and telecom users who are trying to join the cloud native community. Let's go through some of that. So you may not be familiar with them, but CNCF is CNCF or the Cloud Native Computing Foundation. It's a large organization under the umbrella of the Linux Foundation. And the community has cloud providers, technology companies, large number of open source projects. You're probably familiar with Kubernetes. Core DNS would be another one. Prometheus for metrics, observability. Linkerd, that's a network proxy, layer 4, layer 7. Lots of other projects within there. The focus of the CNCF is cloud computing technologies and I'll say methodologies, the practices, as the name implies. So for those who aren't familiar with it, cloud computing is the idea of making hardware resources available on demand. So probably most people would know that. Cloud native is about designing the technology and practices that you're going to use from the point of view that the technology is going to be running in an on-demand environment. So designed from the start. And cloud native builds on existing knowledge and experience from other methodologies like 12-factor development, agile DevOps. From the start, you should expect this type of software to be using CI/CD from the start, like compatible with any type of pipelines, using declarative APIs and configuration, composable services, and be built to be resilient. When failure happens, which will, then it should come back up. So that's the idea. With cloud native, you get all those sort of benefits, which you may have heard, like lowering cost and upfront and ongoing cost, higher availability of services, getting changes faster. So you may already be familiar with cloud native and its benefits. So this brings us back to those target end users. So we're saying the telecom and networking community. And for them, and especially the telecommunication community, the concepts in cloud native, the practices and technologies are relatively new. This community of end users does include both creators of technology as well as networking service providers themselves, those that are taking all the tech and building out larger platforms. The creators could be developers of firewalls, routers, authentication type applications, as well as platforms. And those using the technology in the telco space are called service providers. That may be mobile providers like Orange in France, or Charter Communications, or Telefonica. It also includes cloud providers, so IBM, Microsoft, AWS, all those that you would think of. So what's different about this type of software? Right now, Carl Hoberg is giving a talk on how to write efficient networking applications. Check out the recording after this talk. And so what's different about the telecommunications or applications? What's different? Well, the first part is talking about the terminology and the background. So telco folks will say the industry's been around for over 100 years. There's a large number of standards that were developed independent of other standards. You may hear about if OSI stack, but only very, very, very indirectly. They have their own communication when they're talking about that from a networking side. When you hear 5G and don't think marketing, it's actually a standard, a specific set of technology and baked in practices for developing, deploying, and managing how the software is running. So that's one of the big things, a standard. Another would be the life cycle. You talk 18-month type life cycles just to get something into a lab for someone to test, much less production. So the industry has this very high aversion to risk, and the software and the practices are designed along that mindset. So you'll have stuff like very isolated environments, even when virtualized, sometimes requiring specialized hardware, even for a virtual software. So all of these sort of things lead to problems with trying to adopt modern methodologies like you see in 12-factor app development, agile, DevOps, and cloud native. So this is important to think about when we're talking about these type of end users. So the test suite. This is one of the initiatives that we've created within the CNCF, helping them to help the telecom users. It's a open source tool built for devs, integration, and ops teams to help see how well a networking application is following both Kubernetes, which is our primary focus right now, and cloud native best practices. It's self-contained with a minimal set of requirements to let them get going quickly, which is pretty different for the telco. It tries to provide suggestions whenever things are failing, problems are seen. It has built-in help CLI, which for them, it would be pretty different with a lot of the tooling. And we needed to support a lot of different environments. So some of those may be on a public area, hosted environments, or they could be private and protected. So we even have support for doing air-gapped, where everything is packaged in, and Crystal lends to that on compiling. So we can package it all, have everything offline for running tests. So it's written in Crystal, of course. This includes both the framework itself, which allows us to test actually any type of application on these practices, and the test. They're all written in Crystal. We try to leverage upstream tools specifically within the cloud native community because it helps you to understand the concepts and be more aligned with what they're going towards as far as practices and the technologies. And then we support testing on any vanilla, or you could say conformant Kubernetes. We actually have tools in a separate project that allows you to deploy the Kubernetes on bare metal machines, like Equinix, bare metal hosting provider. And those are available at all to use as well. So a little bit more about the tests. So the tests themselves, those are back to the best practices and principles for cloud native. So these are kind of split up both in the principles and the different areas. They could also be related to if you're on an operations team and trying to deploy packages, then installability and configuration might be onboarding, like getting a new application going. And if you're dealing with how to keep an application up, then there's tests like resilience and observability, so you can monitor the application. So here's a snapshot of some of the tests that are in a certain set that we call workload. So there's a varied set of contributors from a lot of different groups. Those are both the creators of applications, some of those open source, some of them at companies, service providers. So like we have a Swisscom mobile provider that's been engaged on stuff. We have other projects, so ones like Litmus Chaos, which do a lot of stuff for resiliency. And with that, I'm going to turn it over to Will, and he's going to talk a little bit about why we chose Crystal.
Thanks, Taylor. So to dive into why we would choose Crystal for a project in the infrastructure space, it helps to have some background. For instance, on our needs from a language for a project. We wanted a language which was compiled, which would mean we could provide our end users with a binary distribution and less potential dependency clashes than with an interpreted language, since you can distribute only the binary and not the whole tool chain as with a Ruby or Python. And from a developer experience standpoint, we knew we would be wiring the input and output of lots of largely JSON APIs and CLI tools together for the test. So we wanted a language that would provide readable and maintainable code, despite the at times quite complex integrations we would be managing. And we strongly preferred creating DSLs for both. So let's also talk about the choices of languages in the CNCF and Kubernetes ecosystems. Go is the most common language choice by far. According to the CNCF landscape website, which lists many of the projects, at least 243 out of the 354 total projects listed use Go as their language. These projects include Helm, Containerd, and even Kubernetes itself. And prior to ours, 0 used Crystal. But the team had prior experiences with Go in the past and made us want to rethink that default choice, including, but not limited to, problems with error messages not being very useful, package management story being lacking for a long time. Versioning packages was not officially supported in the language, i.e. via shards.yaml in a Crystal project, though this has been addressed in more recent versions. Task management libraries not being very developer friendly, and more subjectively, but in general, just being more difficult to read for humans, especially those unfamiliar with the language. And I'll illustrate a few of these issues. So take a look at this slide here and see if you can suss out what's happening with this Go binary crash. I'll give you a few seconds. Still having trouble? I'll pinpoint the issue. So invalid memory address or nil pointer dereference. That's not good. Any idea what could be causing this? Well, for anyone familiar with Go in the audience, maybe, but if not, not likely. So turns out it's actually JSON. In this case, a body was empty of the JSON body was empty for some reason. And if any JSON the binary is parsing is ill-formatted or missing a field, for instance, you're likely to run into this invalid memory address or nil pointer dereference error. This is a pretty big issue for a project like ours, which spends a lot of time wrangling JSON. This issue is so common, in fact, that there are projects with documentation pages dedicated to explaining this. It don't give much detail outside of it happens for many reasons and is related to the project being written in Go in some way. And generally, it likely has something to do with an API, which could be interpreted in so many different ways. And good luck. So let's also talk about task management in Go. So if you Google Go task management, you'll find the Go task module, which is simple enough for straightforward, simple use cases. But the complexity ramps up quickly when you're stitching together many tasks and variables pass between them. Remember, another important need for our project. So enter Crystal, and we'll talk about some of the things that have been great for us and some of the things that we've struggled with as well. So in choosing Crystal, we get a language that's a lot more human friendly. And you can have your cake and eat it too, so to speak, especially for those that are familiar with Ruby from working in the DevOps community like our team. So let's take a look at this particular slide as well, where we have an issue in JSON, or an issue that the team worked on recently. You can tell that Crystal's error messages related to JSON are a lot more friendly, pointing out exactly the fact that the value is not valid JSON with the error in the JSON parser. And it even points generally to a place in the code where the issue stems from. I'd much rather run into this when trying to debug this particular issue. Also, on the task management front, we've been using the task management library, SAM, to create our task. And it's very straightforward to observe what to do here. You create your SAM file with a task called name, and you can run it with Crystal. And you can even see in the entry point file of our code base, it's pretty straightforward, even without any background on what our code base is doing, to kind of suss out what's going on here. So you have a task called workload. It has some prerequisite tasks that it runs. And then after that, it observes the points that were accumulated throughout the test. And if they're above a certain amount, then the test passes. If they're below a certain amount, then the test fails. Very readable code here. So we've had great success working with Crystal in the telecom space. It's been amazing. Oh, and I can see in the chat, people are commenting that SAM is very reg-like. It is indeed a reg-like task management system. So we've had great success leveraging our extensive Ruby experience almost without a hitch. And we've gone from 0 to 57 stars at this project. And Crystal has been a huge help because of, again, being able to leverage that Ruby experience and being able to write DSLs in Crystal because of that Ruby heritage. So we're going to quickly show a live demo of the test suite in action. So you can see here, at first, we're making sure that we have a working Kubernetes cluster for the binary to connect to. We're quickly downloading a configuration file. In this case, it's going to set up a Kubernetes application called Core DNS, which will act as the CNF. In this case, we'll quickly set up that CNF with the configuration file. And then once that's installed, we'll be able to run our test suite. Yeah, so now you can see that we've run the workload task and that we've got some tests that are running that are passing. You'll see also we have some tests that will be skipped and a test that will fail because this is our demo application. So you can see there, green pass, yellow skipped, red failed. Okay, so back to the slides. All right. So you can see that we've had the successes here of the very accessible code base, as we showed you earlier with the entry point file, much better developer experience with the rake-like tasks of SAM over the YAML files and other configuration things going on with the task management in Go, and shorter time to onboarding for contributors. So we had a contributor who was able to go from making an issue on the GitHub to creating a PR and getting it merged in under 2 weeks, which we definitely strongly attribute to Crystal's accessibility. We've also got multi-platform support, supporting all of the major operating systems, Linux, Windows through Windows subsystem for Linux, and Mac OS while building from source. The upgrading experience was pretty easy. All it took was some version bumps and we were on the next version. But unfortunately, it hasn't quite all been fun and games. We've had some issues dealing with static types and making that work together with JSON. We've also had some incompatibilities with unless and if, where it seemed like it would work well in Ruby to use an unless, but had the unexpected behavior of needing to be wrapped in an if block in Crystal. And some things that we'd love to see in the future would be better ARM architecture support, gRPC, and protobus. So definitely help wanted. We've got some things that we'd love to have the community jump in and help us with. For instance, refactoring the code for best practices. I've got some crazy hacks that I wrote with method missing for the logging code with our recent update efforts, and love to have some people come in and help with that. Wrapping new upstream tools to use in the test suite, and also wrangling those aforementioned static type and JSON issues with Crystal. So Taylor, can you let people know how they can get started contributing?
So yeah, any contributions are welcome, that whether that's documentation type things, or if you want to use the test suite and give us feedback on enhancements or report any bugs, or if you'd actually like to get involved in writing tests, we'd love to see that as well. We have been working on the V10. There is a dependency that I think upstream where we've forked a few things. So if you're working on any of the 1.0 stuff and have familiarity there, we'd love to have some eyes on some of the final PRs we have for using all of those pieces. And we run a contributor meeting on Thursdays for the test suite. You can see the meeting details in the repo. We have a mailing list, and we're on CNCF's public Slack with the test suite and several other projects that are all open source initiatives. You can reach out to us directly on the website if you're interested in Volk helping you, or if you'd like to talk with us about working with Volk, you can shoot us an email, hal@volk.coop, or talk with us on Twitter. We do run a meetup every month. We just had our meeting yesterday on meetup.com for the Austin Software Cooperatives. So if you're interested in co-op stuff, find out what that's about, then check out our meetup group. You can also reach out to myself directly, Taylor, or Will. Here's our info. Let's jump into the Q&A.
Thank you both. Thanks, Will. Thanks, Taylor. Super clear and a fantastic use case for Crystal. We have a couple of questions from Jason in particular. The first question is, can this be used to verify any Kubernetes application?
Yes, Jason. It's not specific to networking application on Kubernetes. It's actually any application running on Kubernetes is current focus. We happen to be doing attributes and tests that are, I guess, prioritizing creating them for networking applications, but those attributes in general are applicable everywhere. State handling would be one of them. Are you dealing with ephemeral state? Are you dealing with long-term state? For long-term, there's practices that you could do that would be taking advantage of the platform versus maybe custom and harder to keep resiliency up.
Thanks,
the other
Taylor.
one, it looks like, is Jason as well.
Yeah.
Okay. Also, does the test suite support operators? So we can test operators. So I guess any type of entity or object within Kubernetes we could potentially look at. We do have a set of tests that we call workload. This really just means the application. If you're familiar with Kubernetes, workload means a simple application or a complex application. It could have any number of components running on Kubernetes. That's it. So that may be in one container or multiple. And then they break down types and everything. So there's a lot of different types that we're trying to support, and operators would be another one. But I will say that some things, and especially if you're going down the operator, may be what we think of as the platform. And that could be Kubernetes based or Kubernetes plus extensions and add-ons, if you're familiar with like the networking, storage, and whatever else you want to talk about. All right.
Thanks, Taylor.
All right. Thanks for having us, guys. Enjoyed it.